Hello everyone. Today we'll solve the sixth of our 145 LeetCode top interview questions. So today's problem is remove duplicate from sorted array. This is LeetCode problem number 26. So given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the element should be kept the same. So we need to remove the duplicate in place. That means we cannot allocate any extra memory, and also we need to keep the relative order. That means the output array will be still non-decreasing order. Okay, since it is impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array. More formally, if there are k elements, after removing the duplicates, the first k elements of the nums array should hold the final result. So as we are removing the duplicate in place, that means we are not allocating any extra memory. So we'll just uh, prepare our output in the same input array and return the k after placing the final result in the first k slot of the num. So in the first k slot of the nums, that means we have to place after removing the duplicates, we have to return the k. That means the length of the new array, not new array, the length of the modified array. Okay, and the rest of the items after the kth index or after the k, it doesn't matter. Okay, here for example, if the input array is 1 1 2, here 1 is duplicate, so we can remove 1, and the output array will be 1 2. We don't care about the remaining item anymore. So let's describe this into more descriptive way. So the problem statement says that we cannot allocate any extra memories. So that is the difficult part. But the easy part is the given array is already sorted. So that is our clue. The array is already sorted. So if there was no memory limitation, we could have just allocate and set and put the all item from our array to set. Then we'll automatically discard the duplicates, as set data structure does not contain a duplicate. Then we can prepare a output array from this set data structure and return the new array, or we could have just iterate through the items and we keep them in a newly allocated array, and we can keep, as they're already sorted, we could have just keep track of the last item and check in each iteration if the new item is equal to the old item. If they're both same, then we could just discard and look for the new item. Whenever we found a new item, we could just insert it into the new array. But the problem statement already says that we cannot allocate any extra memory. Okay, so we have to do it in place. Now the better approach of this problem will be, uh, we could use two pointer variable, one for iterating over the array and another pointer to keep track of our unique data in the array. For example, if this is our data set, then we can keep a index j. This is our initial pointer, and as we have to compare two data, so we can, this is our iterator pointer I will start from next index of j plus 1. Now we can compare both items. So if they are same, that means they are not unique. Okay, they're duplicate. So we need to remove them. But for the programming concept sake, we will just continue iterating. You will understand why. So first we'll check the value of I and j. I mean the value in the index of I and j. There is both is 1, so we'll do nothing, we'll just keep iterating. So our next iteration I will be here. Now the value in I index is 2 and j index is 1, so there is new value, they are not duplicate, so we found a unique value. So in that case we'll increment the j and put our unique value from I to j. Okay, so the new value in the j index will be 2. So this iteration is over. Now we'll move into the next iteration. So I'll be incremented into this place. Now again we'll check the value between I and j. So we can see the value is different, we have a unique value. So again we'll increment j and move the value of I into j. So this iteration is completed. Again we will iterate I into the next. So now our current value of I is 3 and current value of j index is also 3. So they're same, they're not unique. So we'll do nothing, just keep continue iterating. So I will increment it in this place. Now we'll again compare the value into I index and j index. Now this is 4 and this is 3, so the value is different. So whenever the value is different, we need to increment the j and put the value in I index to j index 4. So as you can see, this is our new array. Okay, this is our new array, though there are element in the remaining part of the array, but we already go through all the element and we can say this part of the array is already sorted and all the duplicates are removed. Okay, so in the description they say we have to return the k. So k is the actual length of the our array that does not contain any duplicate. So this is k. Our current index of j is 0 1 2 3, but the length will be 4. Okay, so we need to return j plus 1 at the end of the program. J plus 1. I hope you understand the description. Let's get into the solution. So first we'll check for any empty value. Now we'll declare our two pointer value. Now we'll iterate over the given array. I will start from j plus 1. As you remember, if the value of the both index are same, we will do nothing. But if they are not same, uh, then we found an unique value. So we'll move up the unique value into our j index. And at the end, we'll return our length. Let's compile this code. So it compiles fine. Let's submit it. Okay, we have accepted our problem. Thank you for watching.